Hello viewers, in today's class we are going to discuss one important problem related to finding out the point of inflection of a given curve, right? So the detailed video on how to find the point of inflection and the concept of inflection has already been discussed in our earlier videos, and here we'll solve this problem, right? So here we have to find the point of inflection of the curve y is equal to log of y over x, right? So here let us quickly see the conditions for which the point of inflection exists, right? Suppose we are given a curve y is equal to f of x, right? So now this curve has a point of inflection if the second derivative of y with respect to x is equal to 0, right? So the necessary condition for the point of inflection to exist is that the second derivative should disappear, right? Or the second derivative must be equal to 0, right? So this is the necessary condition. And further, the third derivative of y with respect to x should not be equal to 0, right? So here we have these two conditions for the point of inflection to exist, right? So let us apply these two conditions for this curve to get the point of inflection. So now here the equation of the curve is x is equal to log of y over x, right? So let us first express this equation in this form, that is y is equal to f of x. So for this what we will do, see here we have x is equal to log of y over x, and the base of the logarithm is e, right? So we can rewrite this equation as e raised to x is equal to y over x, right, from the definition of logarithm, right? So now we have y is equal to x times e raised to x, right? So now this is of the form y is equal to f of x, right? So now let us find out the derivatives of this function with respect to x. So the first derivative is dy over dx. So here we can apply the product rule. So we have x, then derivative of e raised to x is e raised to x, then we have e raised to x, and derivative of x is 1, right? So we have x e raised to x plus e raised to x, right? Now let us find out the second derivative. So differentiating dy over dx will get d2y over dx2. So now we can differentiate again this function. So here again we'll apply the product rule. So we have x, then e raised to x, then we have e raised to x, and derivative of x is 1, and here we have the derivative of e raised to x is e raised to x. So we have x e raised to x, and e raised to x plus e raised to x is 2 times e raised to x, right? Now let us find out the third derivative, right? So the third derivative is d3y over dx3. So the derivative of this function is again calculated by using the product rule. So we have x e raised to x, then we have e raised to x, and derivative of x is 1, and here we have 2 times e raised to x. The derivative of 2 raised to x is e raised to x, right? So now we have x e raised to x, and 2 times e raised to x plus e raised to x is 3 times e raised to x, right? So the third derivative is now equal to e raised to x and x plus 3, right? So this is the first derivative, this is the second derivative, and here we have the third derivative, right? Now to find out the points of inflection, let us apply the conditions. So the necessary condition for the point of inflection to exist is that the second derivative should be equal to 0, right? So here we have the second derivative, which is equal to x e raised to x plus 2 times e raised to x is equal to 0, right? So now we can rewrite this equation as e raised to x and x plus 2, taking e raised to x common, and here we have 0, right? Now see, e raised to x is not equal to 0 for any value of x, so this factor should be equal to 0. So we have x plus 2 is equal to 0, so we have x is equal to minus 2, right? So here the only point of inflection is x is equal to minus 2. So now let us test whether the third derivative is not equal to 0 at x is equal to minus 2, right? So for this what we will do, we'll take x is equal to minus 2 in the third derivative, right? So d3y over dx3 at x is equal to minus 2 is equal to, here we'll take x is equal to minus 2. So this is e raised to minus 2 and we have minus 2 plus 3. So this is 1 over e square, and here we have 1. So this is 1 over e square, which is obviously not equal to 0, right? So this point x is equal to minus 2, it satisfies this condition, that is the third derivative is not equal to 0 at x is equal to minus 2, right? So now we can claim that this point x is equal to minus 2 is our point of inflection because it satisfies both these conditions, right? So for x is equal to minus 2, let us find out the value of y, right? So y is equal to minus 2. Here we'll take x is equal to minus 2. So we have minus 2 and e raised to minus 2. So this is minus 2 over e square, right? So the coordinates of the point of inflection are now given by minus 2 because x is minus 2 and y is minus 2 over e square, right? So the coordinates of the point of inflection are given by minus 2 comma minus 2 over e square, where e is the exponential number, right? So viewers, this is how we can find out the point of inflection of a curve when the equation of the curve is given in the Cartesian form, that is y is equal to f of x.